bum, 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 bum. Bum, bum, ba-dum, bum. Ah, I think I'm streaming. Huzzah, we are alive. All right, let's go tell the world. Streaming some pixel art for Procjam. No, that's not what I wanted. What the? All right, there we go. So what we're going to do is create some basic pixel art for the characters that are going to buy your stuff, buy your planets. And that just means we're going to create some basic split image stuff, like a sort of like South Park, but we're not going to have the same aesthetic. But in order to do that, we are going to want to sketch up some stuff that feels right. Let me settle in here. Oh, I just finished winterizing my windows. Oh, and there is a real risk of me... Hold on, I got to fix this. Ugh. Come on. All right, there we are. Sorry about that. A pin had fallen off of the wall and straight onto my lap. So thought it would be better to put it back in. All right. So what we're going to do is we're going to paint up some characters, and I've accidentally made this in millimeters rather than in pixels. I don't know why it's defaulting to the wrong thing now. So we're going to make some really, really tiny characters, and then we're going to blow them up and make them look all pixely and distinct, right? Should be pretty straightforward. And the idea being that they're going to look like aliens and robots and stuff. And we're going to start with a really basic one, where we're just going to sketch out some eyes and a little robot mouth. And then what we'll do is we'll create our own transparency layer, because that is not going to be what we want. And we will fill it with our character's color, which I'm probably just going to go with no red, green, or blue, just all gray tones. We could use, faster tools and stuff, but I just got home, so I'm sort of using this as a warm-up as well. This is going to be very, very basic. And we'll just create some shadowing so that it looks like it exists. There. And now what we're going to want to do is export that as a new element. Call it robot 1, robot 0. And then for the backdrop, we're going to go ahead and sketch in a backdrop for the rest of the face. And this is obviously just a quick little setup for our purposes here. We'll go ahead and flatten this down and make it more transparent so we can see what we're doing. And we'll just go ahead and create a mouth for it that it can wobble around on. Like that. And we'll fill that in. Let's use a darker gray just because that's closer to what we're going to need for most of it. Now let's put in some shiny. I guess this gray is a little too dark, so let's just lighten it up a little bit until it more or less matches the gray up there. Like that. There we are. And there we have a very, very basic character. And let's go ahead and animate it. Save it as robot 1. Set aside our sketchpad for a moment. And let's put it into Unity and pop it up and animate it. And hold on, I've got my sketchpad tangled up in my microphone wires. Really doing wonderful work today. All right, so we've got a scene here, and it is with the sun and the planets and stuff. What we're going to want to do is create a new scene, and the reason for that is because the UI is just its own thing. And so to do that, we'll create a UI element. We're going to need a canvas, obviously. Inside the canvas, we're going to need a panel. The panel is going to be on the right side of the screen, like so. It's going to have a specific width, which we're going to go ahead and make, I don't know, 128 pixels. And we're going to want to anchor it at the correct position. Wrong one. Try it this way. There we are. 0, there we are. And that'll put it right up against the edge of the screen. We can pull it away from the screen a little bit, like 5 and 5 and 5. That should do. Oh, -5, my bad. And then we're going to go ahead and make this a vertical layout group. And we're going to force the height. No, wait. Well, we'll figure out what we're forcing in a minute here. Zesh says hi. Zesh. So what we need now is another panel, or could be anything, I suppose. In the long run, we're going to need buttons. Let's make them buttons now. So the button is going to be a specific size. It's going to be a layout element with a preferred width and height of 128 and 128. And what we're going to want to do is, for the panel, we're going to want to make it so that that is correct. There we are. And so this button is going to be a character. And what we're going to do is we are going to make it so that the button doesn't have an image or text on it. And so we're going to remove this image just because it's not where we want it to be. We could put it in as, you know, the face of the character is there, but that would mean just one layer of the face would highlight, which would be really weird. So we're not going to do that. But we are going to go ahead and add in some elements, some image elements. Here's one. We'll go and make that max size, and then we'll drop in our new characters, which are not set up as sprites. They're set up as images. So there we are. And we're going to want to make sure that those have the correct alpha. Yeah, that looks all pretty good. And now when I grab this guy, I should be able to actually drop the image in like this. And then if I duplicate that and bring it down, I can drop the other image in like this. And so we'll have a face and a neck. And then we'll just bobble it around like it's you know, something from a children's show or something. Now you can see that what we've got here is a very blurry pixel scale up. I believe that we can change that here on the image. Yeah, there we are. And by changing it on the image, it allows us to get the proper scaled up pixel look. Now there's no frame around it, so up here in the button, we're going to go ahead and add that graphic back in. Oh, I'd add it here, hold on. Image. And we're going to go ahead and call this one a boom, a panel like this. But you can see that it ends up behind our sprite character. And that's kind of obnoxious, so we actually need this to be another one of these guys. So we'll just go ahead and call this the front panel. And we'll remove it from here because it's not working out for us. And we will, boom, put that in the front panel like this. Boom. And boom. How come it's still in back? Oh, I have to put it in back. I'm an idiot. I got the rendering order backwards because it's been a long time since I've done this. And there, now we have a robot guy on your communal phone, or your cellular sci-fi phone. Only problem is that this here is not quite right, as you can see. So what we actually need to do is bring these down a little bit. And the way to do that is just to select both of them and give them just a tiny bit of border on all sides. There we are. And now what we're going to need to do is actually animate them. So that's going to be here on the button. We're going to create an animator. And we're going to create an animation handler for each of these. So they're all going to need their own animation handler, I believe, animation controller. And we'll just drop this, call this robot, and drop it in. Boom. And so we can now create animations for it. There are a couple of animations we're going to want to make, and I haven't really decided on the full extent of them. But basically, we just want their mouths to move and their heads to bobble. So that should be pretty straightforward. So we'll just go ahead and... Why can't I... Create. There we are. That's fine. We're going to call this Robot Talk 1. And we're just going to go ahead and move things around. So we're going to be doing a lot of wobbling and bobbling. I'm actually not sure whether or not it can be done live, but even if it can, I'm more used to not doing it live. So, you know. Anyway, we're going to do it with these controls because these controls can let you do all of the things you need to do right away without any sort of confusion. So we'll go ahead and hit record, and then it'll allow us to place this object wherever it needs to be. So we're just going to bobble it a little bit. That's not what I want to do. I want to bobble it a little bit. Basically, these values have to come back to 0, and there's... Can I just double-click to create? No, I can't. Of course not. Unfortunately, the annoying thing about this is that there's no way to tell the animation to put a nice cap on the end, short of just rotating and then rotating back, which is dumb as hell, right? That's really stupid, but whatever. And then we'll just move it and then move it back. And now, between these two, we can make it do any motions we want in order to give it that nice bobbly feel. So, for example, we can have him go and then tilt a little bit, because that will look kind of fun. And then we'll bring him back down like this and maybe bobble him the other way. And then we'll have him go back down and leave even further. And I think that these are in the wrong order, but that's okay. We can reorder them after the fact. It's pretty straightforward because they're name-based rather than order-based. Oh, it's not recording anymore. God damn it. What a waste of time that was. Unity's recording system has always been a little bit weird. I think that if I used it a lot more, I'd get used to it. But guess what? I don't use it very much, and I'm not used to it. So for some reason, the offset isn't getting fixed. Oh, because it's just that... So the top and the bottom animate separately from the left and the right. That is amazing. I did not expect that at all. There. So now if we hit play, we can get like a... That low dip in the middle feels a little awkward, so I'm going to go ahead and explosively escape from it. There we are. Yeah, I was recording. Good. So sometimes it records and sometimes it doesn't. It's like, I'm going to bid on your planet. That should be pretty easy. This is just a very, very basic interface because it's something that we're doing for a game jam. We can't really afford to spend too much time on this stuff, right? But we'll just go ahead and hit play again. Yeah, that seems fine. And so for the animator, what we're going to need to do is we're going to need to have... Oh, that's not the same animator. Interesting. There we are. We're also going to need to have an empty, but we can just add the empty. We don't need to recreate it. Over here, we're going to go ahead and create a new bool called talking. And we're just going to have this transition between the two whenever it changes. We could also create a trigger, but in this case, the triggers would be a lot less reliable. So we'll just do it with a bool. And later on, we can make this more polished if we need to, but I don't think we're going to bother. I think it's just going to be like very, very basic. We're going to need to take this set of objects and create one more that is a backdrop, which we're going to go ahead and make a 1, 1, 1, 1, and set it up with just a flat backdrop. Did I not? I didn't. I'm an idiot. Okay, so I actually have a third sprite called blank, but it's blank white. There isn't a blank white in Unity, so it's good if it exists. Oh, it's the wrong size. Okay, well that's fine. We'll just go ahead and save over it. There we are. And that way we'll have this as the blank white. But we don't have to have it be white. We can change the color to, say, a strange blue, there, like that. And now we'll have a backdrop for it. And that means that we can take this panel and make it so we can't see it. There we go. Now, we don't have any text box for this yet, so I think that's going to be our next stop, creating a text box so it can talk. We're going to want to have at least 4 characters to bid on different aspects, but for now, we'll go ahead and stick with just this one robot guy until we have him more or less working. So we're going to need a new panel here. And this panel is going to anchor to the left-hand side of our base object. So we can do it like this. And then we need it to have a width and a height. We'll just leave those as they are. The height, rather. For the width, we're going to go ahead and make it maybe 256. Maybe a little bit even wider than that. How about 312? That's probably okay. Let's see how it looks once we add in a canvas group. Yeah. Once we add in a text box, we'll know more about whether or not that's a good size. I'm going to just set this text box up. Set up a 333. There we go. And we'll go ahead and give it some boldness, because the default Unity text is almost illegible at small sizes. And we'll say, I like this planet. It's robot-y. And just to see how big that is, you know. I don't think we're ever going to need that much text. So we'll go ahead and alter this until it fits our exact needs a little bit better. I don't think we need this level of height, so let's go ahead and reduce the height down to 60, and then we'll move the whole thing up until it is like up here, so it feels like he's saying it, right? And that way we now have something where we can make him say stuff and he'll talk, but in order to do that, we're going to need a new script, so let's create one. Talking head. Our talking head script is just going to be responsible for wrangling all of this nonsense. Wait, did I accidentally put it on the panel? Okay. Boom. Open it up. We're going to need to take in an animator and a text file. So for those, we're going to need to have a using Unity engine.ui. And boom. Public animator. I think we need to put in a new. And public text box. Or is it just text? Text. There we go. And then we'll have a protected string convo and protected float counter. Then we'll just go ahead and create our talking elements. So public void talk, or say, string line. And then we'll go ahead and have that conversation get converted. So we'll go ahead and say animator dot set bool talking true. And then we're going to go ahead and say convo equals line and counter equals 0. And then down here we'll have in update if counter is greater than or equal to 0. Here we'll make this -1 just by default so it won't start trying to say nothing. If counter is less than 0, then return. Otherwise, we're going to add time.delta time to our counter, and then we're going to come up with a new string. So if counter is greater than convo.length, so string text. Okay, so we've already got a string text. This should be text box so we don't get confused. So string text, and then here we'll say it equals convo. And then if we don't have as much as the convo length, we'll say that text equals convo.substring 0, comma counter. And I think this is going to be too slow. Let's go ahead and add in a public float text speed, and we'll make it equal to 5. And then we'll just multiply delta time times 5. And then down here what we'll say is if counter is greater than convo.length times 3, and we might change that later, then we're going to want to animator, we'll just have it, we'll actually just have it be times 1.2 here. Animator.setBool talking, comma false. And there's one more thing that I forgot about. We actually need to have it pop the text box into existence. We're not going to want to have all of the text box up all the time. So public canvas group, We could have a separate animation for that, but then we'd need to use animation layers, and that sounds annoying, so we're not going to do that. I have time multiplied by 5 instead of text speed. You're right, I do. Thank you. You keep paying more attention to my code than I am. So when we actually set the bool here, we're going to go ahead and turn the canvas group on. Oh, we'll go ahead and just, this is not, I think it's to 1? I think so. So what we're going to want to do here is canvas group dot alpha equals mathf dot, what is it, clamp 01, convo dot length divided by counter. So what we actually want to do is have this after we get to our length. I'll have it start to, well, you know what, I'm not going to bother. If counter is greater than convo.length times 3, then counter equals -1. And I bet I got a better idea. It's going to be counter length times 2 plus 10, something like that. Counter equals -1, and animator canvas group dot alpha equals 0. And that should allow us to say something. So we'll go ahead and here in start, we'll just say something to test it out. I am the very model of a modern major general. And we'll see whether I've made any errors. I have. Oh, we need to have a counter here. mathf dot floor to int counter. Or seal to int would be better. Anything else? No. Okay. So let's go ahead and hit play. I like this planet. It's Roboti. Oh, I forgot to actually assign all of the elements I need to assign. Brilliant. Okay, so I'll just drop these elements in where they're supposed to be. And then we'll hit play. Oh, I forgot to actually set the text box. I'm so smart. Textbox.text equals text. Wow, that's not 5 characters a second. That's 1 character per second. Time.delta time times if counter is less than convo.length. Counter. In theory, that should be 5 characters per second. It feels a lot slower than that, doesn't it? Let's go ahead and just triple it and see whether it goes 3 times as fast. Yeah, I guess it is. I guess my sense of timing is off. There we are. So now you can see that we can have these characters say things. The other thing we're going to want to do is, in the animation that I've just created, we're going to want to alter it so that it... there's something else we're going to want to do with this. I think we're going to need to have a new animation, because what we're going to need to do is change the color of these characters so that we know who's talking. So what we're going to do is we're going to go over here and say create a new clip, and we're going to create a new clip called Talking Now, or highlight person. And what that's going to do is it's going to just change their color from something dim to what it is now. The problem is that if we do that, then we're going to end up having a situation where we can't change the colors here in Unity, and we have to change them in the drawing program, because otherwise they'll get reset. So what we're actually going to do is we're going to assign a canvas group to this entire object. And then we're going to alter this canvas group and that canvas group separately. So we're going to go over here to 0.2, or no, 0 is fine. And we're just going to go ahead and change this to 0.7. And that should give it a faint enough look that it should work. So we record 0.7 is what it's going to be at the start, and then it's going to be 1 here. And that should make it so that these things pop into existence. However, the canvas group for the panel is going to start at 0. And then it's going to rise up much more slowly to 1. Let's go ahead and make this 0 last a little bit longer. So, there we are. And then we'll reverse that when we need to stop talking. So that's one that doesn't get looped. We'll go over into the animations and tell it not to loop. Highlight person, don't loop. We'll go over here into the animator and set this up as the in and out for robot talk. So the way to do that is to have the entry here. So we need a duplicate of this that is a de-highlight person, and runs at -1. And from the any state, what we're going to want to do is transition into highlight person, and then transition into robot talk. And then from robot talk or de-highlight, we can just transition straight into de-highlight. So what we're going to do here is this nothing happens is going to work okay, but the problem is that when we go to de-highlight, it's going to end up... So the any state problem is that this can go in from any state, meaning that when nothing happens is here, these can still fire. If we go from nothing happens to de-highlight, it's going to flicker into full opacity, and then it's going to fade away, and it's going to look really strange. So what we're going to do is add in a talking of false here, and that means that it will end up going to de-highlight immediately as soon as the game starts. However, we should be able to tell it not to be able to transmit, can transition to self as false, interruption source. I actually don't know what that means. I was under the impression I could tell it not to transition from specific elements, but it doesn't look like that's true. So we're going to go ahead and do it the annoying way, which is that we're going to have 2 identical transitions where talking is false, one for highlight person and one for robotalk. There we go. And that should work fine. And that way what we'll do is we will get a pop into full highlighting, and then a talk, and then it'll de-highlight. Let's try it. Well, it's still looping, or I forgot to tell it not to transition into itself. The fact that that's not default is really dumb. Okay, so now it is looping, even though I told it not to loop. Let's take a look at what the animator is actually saying about itself here. Drop it over into another screen so we can see it a little bit. Hit play. Okay, so the problem is that The any state trick isn't going to work here, not unless I think about it a little bit better. It's just not going to happen because it keeps transitioning over into the start state, which makes it a little bit hard to control. So we'll transfer from here, and then from dehighlight, we'll transfer back down if we are talking. And that'll have the same effect, but without the stupid chattering side effects. Okay, let's try that again with the scale set correctly so I can see stuff. So you saw how that flickered out and then flickered back in? That's kind of what I wanted to avoid. Is that because the start state? I know what the problem is. The start state here isn't 0. It's only 0 in the animation. So now if we hit play. Oh, well, that didn't work. What? So let's take a look here. What went wrong? This shouldn't be hard. This is super, super basic, and I'm just screwing it up because I haven't done it in a while. Okay, so I see the problem. The problem is that robot talk doesn't have it set to being opaque. So we're going to go ahead and tell it that it's opaque. I guess we also need to tell it that this is opaque. There we go. Now it's working. So we have this whole alpha thing in here we no longer need. We'll just delete it. We don't need it because we already do it with the animation. So because of that, it shouldn't have any problems. Oh, yeah, we have the set bool talking equals false. The only problem is that the set bool talking equals false bit, that's going to trigger really, really fast. Watch, see? So what we need to do is have a slow fade out inside of the animator. This transition needs to take a really, really, really long time. So we'll make it like 3 seconds just to see what happens. Oh, that's the exit time. That's not what we want. Undo. Darn it. This here, transition duration, 3 seconds. Let's try it out, shall we? Yeah, that's good. Good enough. We'll just change this to be a little bit longer. So all of that should make it so that we can have little robot friends that talk to us about our planet. And these are all going to be willing to buy our planet for whatever pittance they will allow. That's not working. God damn it. The problem is that I need to have a done talking and then also a dehighlight. They need to be separate. So that's really obnoxious. So I need another nothing happens animation, but the problem is that this nothing happens animation isn't properly tied to our units. So we're going to have to create our own nothing happen animation here. Create new clip, nothing happens robot. And this nothing happens robot, we'll make the transition, then we'll make the transition. Here will be deleted. This will be if talking is false, we transition over to this. Now, the nothing happened robot needs to have the these objects set to full opacity, which is why it needs to be different than the other one. I don't think that I think I could have done this a lot better. I just, however, did not. So we've just set this up, and what we're going to do is we're just going to go ahead and make it 3 seconds long. Yep. There you are. And then we're not going to make it loop. We're just going to go ahead and set it like this. And that should now work in theory. This automatically happens regardless. Yeah, let's try it out. That's fine. All right. Good enough. So now what we've got is a situation where our robots can talk, but nobody knows how to make them say anything or do anything or who they are. That's going to be our next step. We're going to have them talk about the cities that you've created. So we're going to go ahead and save this as our robot Congress. I don't know, our robot. I'll call it our Robodex. There we are. It's our Robodex. And we'll just drop that in as a prefab. Boom. Other thing we need to do, this cannot be selectable via navigation, because otherwise you'll accidentally click robots, and that would be dumb. So we'll go back on over to our normal set of our normal display here. There it is. So we got this issue where we can't actually interact with the planets yet. So that's going to be what we need to do now. We need to make it so that the various operations here make stuff happen. So we're going to need to have a UI here that's either separate from or integrated with the robot elements. I think that separate from is probably better in this case. So we're going to have two canvases in our world. This canvas is going to be the UI for controlling our camera with the mouse. We're also going to allow you to control it with keys. They'll both work. So to do that, we're going to need some buttons. We're going to go ahead and have a camera off, please, because it's really, really bright. We're going to go and have a button for going right and going left. And we'll want to attach them to the relevant corner of the screen. And we'll set up the text. Next. Oh, I just make it this. You know what? I think we're getting ahead of ourselves. Let's go ahead and make the key version first, the one where you can control it just by hitting left and right and stuff. So this is the Clickmaster. It's going to be the same thing. One thing we need to do is here in public void start. We're going to. We won't get a start. I don't believe we get an awake either. So I can't do it, can I? I can't. Okay, whatever. We'll just deal with it. Because I keep leaving it turned off, and I really want to turn it on when I run the program. I don't believe there is a function that runs when your object is disabled and you hit play, but I could create a really simple script to do it. We'll just do that. Start, enable something on run, on start. And we'll drop this on something that actually exists, like, say, the event system. Apparently that is now completely worked out. That's fine. Public game object target. And then here we say target dot set active true. And now we shouldn't have any more problems with the camera being turned off when we hit play. Perfect. And then up here, we're going to start to test out some of our other control options. So we're going to close a lot of these objects. Right. And here in update, we have a check for a click. Well, we're going to make things a lot more complex than just checking for a click. But for now, we're going to want to add in the option of checking for horizontal movement. So public my butt float horizontal equals input.getAxis horizontal. And then we're going to just offset ourself by that much. So transform.position plus equals vector3.right times horizontal. Yep. Okay, that's really fast. Times time.delta time. Better. So now we can go along and figure out what we're trying to do here. If we click on a planet, we do zoom in on it, but there is some very, very screwy stuff happening. I think that some of that is the animation being called after our camera gets called. So we're going to want to do maybe a late update on the camera track. Because I think the animator is actually happening after the camera, which is giving us that really weird juddering feel. Yeah. So that's easy enough. There are still some things we have to do, though. One of the things we have to do is we have to tell the planet to be a little bit smarter about this. So you can see here we do this zoomed in on, where if we click on a planet, we set the zoom equal to true on that planet. What we're going to need to do is have that planet actually check and see whether or not it needs to have its parents also set to highlighted, because otherwise the scaling isn't going to work out. So to do that, we just go down to the set highlighted or set active, or whatever you call it here, set zoom. We'll go ahead and say planet p equals get component in parent planet. If p dot set bool zoom p dot set zoom, sorry, p dot set zoom. That way, when we look at a moon, we'll get the actual correct scaling. So let's go ahead and just take a quick look and see whether that works. So here we've got a moon. So what we should see here, when we click on this moon, this will move up and the moon will move up. We'll end up blasting past the planet. Oh, that didn't work. That was interesting. What happened there? Stack Overflow exception. Is getting it in the parent actually getting it on this object as well? I bet it is. Oh, God damn it. Okay, so what we're going to need to do is transform.parent.getComponent. Do we have anything with a moon? We do not. Try one more time here. There's some moons. So if you click on one of these, yoink. Huh. Hold on. Oh, that's right. There is a container object. I forgot about that. Although we can just do, yeah, well, whatever. We'll just hard code it because it's a game jam game, and who the hell cares? Because of the animation style, we have to hard code that value inside of another. The planets are not inside of their parent directly. They're inside of an empty object that's inside of their parents. There we are. That's what I wanted to see. Correct. Thank you. So now what we need to do is have those actually correctly adjust the scale of those objects as well as their position. So right now, drop that in, go over to animations, and you can see that we just adjust the Z value, like so. So if we go down to the Earth-like, we should be able to see it rising, yeah. We're also going to want to adjust the scale. So to do that, we're going to hit record and make it 111. And then it's going to go back down to 0. So here, perfect. And we'll just go ahead and call that done. And what we're going to need to do, I didn't mean to delete it, my bad. What we're going to need to do is add an event, which we'll add it. The problem is that we now have, if we add an event, it's going to be either on this side or this side. So we may need to have a separate zoom away from planet, which is okay. We'll just duplicate this one. But the animation event we're going to need is to rerun our system here. But you can see that run doesn't appear to be an option. It should be. Is run reserved? I think run might be a reserved keyword. Public void animation event run shortcut. Run. What? Run. Jesus. Okay. Fine. Now let's try this one more time. We want the animation event to call run. Or the animation event run. Run shortcut. Why isn't run in here? That's so weird. It must be reserved. Run must be something that happens inside of the animation. And because they're using this really, really clunky, ancient method of choosing what's going on, they can't have us able to call run. It would be recursive. They're too stupid to be able to allow us to pick which object on the object gets called. So we'll just do an animation run shortcut here. And that will end up recalculating it when we hit the end. But we're going to need to create a duplicate for shrinking the planet. Zoom in on planet. Zoom in on planet 1. That's not going to be a zoom in on planet 1 though, is it? It's going to be a zoom out on planet. And we'll go over here into Earth-like. And we'll just drop it into the animator. It'll pop up right down here once we see it. And this is zoom out on planet. Make transition, make transition. So if we're zooming out, then we want to be zooming in. And if we're zooming in, then we want to be zooming out. But we still have to set it up. So for zoom out on planet, we're going to do the exact same thing we did, except we're going to reverse it. So excuse me while I get the hiccups in front of you. Drag this over to 2. And then drag the whole thing over here. There, perfect. And that should now do the exact opposite. And that should allow us to zoom in and zoom out and then recalculate the exact visuals whenever we do that. Now, the only problem we really have with this approach is that scaling this up is going to end up having it double up. So this doesn't look right. Oh, there's just an Earth-like stuck in the... Sorry, my bad. So the biggest problem we're going to have is that there are going to be things that are a little bit wrong, and I'm not sure what's going on with that. For example, this moon-like is at scale 111. It's all at scale 111, even though it should be at 0.5, 0.5, 0.5, unless for some reason it has decided that, no, So if we look down into our moon-like, did I accidentally leave it at 111? I might have. I did. Because nothing happens is not going to change their size. Oh, that's a planet slot, idiot. Yeah, this is all fine. Yeah, so let's go ahead and try that one more time. There we go. So now if I click on this guy, zoop. Oh, it bounced. That was odd. It shouldn't have bounced. Hold on, did I screw up the zoom true, zoom false, zoom true? Why did it zoom out? Let's get a closer look at what's happening when I'm clicking on this stuff. Okay, so zoom. Well, I don't have it selected, which is probably why it's screwed up. What's going on here? That should be that hot planet. All right, so let's select the first hot planet. Here's the first hot planet, and if we click on it, it doesn't seem to do anything. This does not trigger in the slightest. So is this not representing it correctly? So for some reason, this animator is showing all animators instead of the one that I want it to show. That's strange. Usually it shows the correct... usually this is the animator that's... Oh, I'm not clicking on the planet. Okay, that's the problem. There we are. So here you can see the nothing happens animation happening. And if I click on this, it goes to zoom in on planet, and then it stays zoomed in, but that's not the zoom in on planet animation. That's not what happens in the animation. Unless I accidentally changed both animations, and that would be annoying. I might have done just that though. So if we take a look here at the animation, zoom in on planet. Okay, so zoom in on planet and zoom out on planet are reversed. Fantastic. So somehow I managed to edit the wrong animation. Well, we'll just go ahead and rename them. Zoom out on planet and zoom in on planet. And here we'll make this one zoom out. And if we take a look at the animator, is that going to be broken? Okay, so we're just going to go ahead and switch these for the correct animations. There we go. And now we're going to delete this planet and try one more time. So now if I click, nice, right? So the issue here is that we're not actually zoomed in on this planet enough to see it at full scale. We're at half scale. So if I were to look at this, you can see that's at 111, but this planet in here is also at 111, but the sun is at 0.5, 0.5, 0.5. So in order to see it at full scale, we still have to zoom it up by another factor of 2. So what we need to do is we need to have a flow chart for our ClickMaster. We need to have a set of parameters. Public enum interaction state. We're going to go ahead and say this is a galaxy map, solar system, planet highlight, and planet settle. Okay? So that's fairly straightforward. And then down here, when we do our planet zoomed in on thing, this is going to be highlighted or selected. And then what we'll do is when we click, we'll have a very different result depending on what we're doing. So here we check and see when we try and click on something, we get this planet, and then we say if it's what we have been selected, if it's what we selected, then run our city thing, and that's not what's going to happen anymore. So we're going to have a public void click on selected, as opposed to the other one. So this is what we'll see if P is equal to selected, then click on selected. And then down here, we'll add this. So the issue here is that we actually need another animation. P is the planet, so we got that selected. But to hit the texture chord, we'll have to take that in. Vector to UV chord. We need another animation that's going to be almost identical to the one we created. Oh, except where I just barfed it here. There we are. We need another animation that's almost identical to the zoom in, except that it zooms in twice as much. It zooms in from 1 to 2 rather than from 0.5 to 1. That's not too difficult. We can do it in a lot of different ways. The easiest way is to duplicate the zoom in on planet here, and then we'll name it focus on planet. And then over here in the animation, we can just edit it right here, but we're going to want to add this to our planetary prefabs. So just grab this, go over into Animator, and you can see that there's no Boolean for it or anything. So we're going to want to add in a new bool, which we're going to call focus. And we will just go and animators. There we are. We'll go ahead and put in the focus on planet in here. And when we go over to the animations, we should now be able to use the focus on planet and properly see what's going on. So you can see that it does that. That's actually not what we want it to do anymore. So we're going to just go ahead and delete these guys. Yeah, those guys. And then these guys, we're going to bring them back here. And then over here, we're just going to go ahead and increase the scale record, please. 222. And that should bring us all the way up to maximum resolution, which is what we want. So that should work out just fine. And that shouldn't have accidentally damaged anything, which is kind of good. So what else do we need to do? I think that we need to actually rig it up. So right now we've got this focus system happening, and if we are focusing on the planet, we're going to want to trigger this. So focus true. And then if we're not focusing on the planet, we'll just do focus false. And we will rely on the just the blending to take us out from that. Our camera will be moving away at the same time. So now that that is the case, we can set this up to correctly call all these values. So here in click on selected, we're going to do a switch. What did I call it? State. I guess I didn't set it up. Public interaction state equals solar system. So switch state default debug.log warning. Somehow clicked on a planet before selecting it. Oh, well, that's actually, I actually don't need that. I'll just go ahead and have it just go straight to selected. So case solar system. Then we'll just say that state equals interaction state dot planet highlight, and that we will set the set zoom here. Boop. And then down here we will say if you are already on the planet highlight, then we're going to want to actually go all the way into our planet settle mode. And that means that we're going to want to have set settle true. Obviously that doesn't exist yet. And then otherwise, we're going to want to say that if you're already in the settlement mode, then plonk a city down. Right? So that should work. Only thing we need is now a set settle. So down here, we got this set zoom. We just copy it and paste it. This is going to be set settle. And I believe we named it settle, not delta. Oh, this doesn't happen though. It's just us. It's focus. We called it focus. That's fine. So with that in mind, we are also going to have a click off selected. Public void click off selected. There's a lot of things we can do here. So hold on. Bool recursive equals false. Switch state. Case settle. We're going to want to go back out. We're going to go back out to highlight and set the settle to false. Case of, and we're break. And if we're on planet highlight, we're going to go ahead and set these to solar system and then selected.setSettle set zoom false. And then we'll just do selected equals null. And there we can now click off. And then here what we're going to do is we're going to say if recursive and state equals planet highlight. Click off selected. There we go. So that should make it so that we can select or deselect as we see fit. So here we have this click on selected, and then if we're clicking on something that's not the selected, we got two options. Either we have something that's selected, or we're now selecting something for the first time. If we're clicking away from something that we've already selected, then what we're going to want to do is just remove, sorry, I'm trying to think of the best way to do this. So we're going to want to deselect. So if P, then click off selected. True. If selected, sorry. And then otherwise, we're going to go ahead and set selected to P and then click on it. And that should work, I believe. The only thing I really want to do in addition to this is we want to have an if input.getMouseButton down 1. We're going to want to click off selected, just one layer, because that way we can zoom in and out. Oh, I left the planet in again. Deleted. All right. So with this in mind, what we can do is we can go over here and click on this moon, right? And it'll go whoop. Bump, 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 bump. So there's obviously something going on here that's not correct. I'm not sure why this main camera malfunctioned so badly. So if we take a look at this moon that we're in front of, which I think is here in the Earth-like, you can see the Earth-like scale is 2. The Earth-like is not what we clicked on. We clicked on the moon-like that's down here, which is also now 2. So the reason these are so big is because both of them are happening at once, although I don't know what's up with this nonsense here. That is definitely wrong, but I have a feeling it might be because we tried to do several things at once and screwed it up. Somehow, the Earth-like got its animator focus isn't set. It should be zoomed in on the planet. Did I change it so that... Okay, I was pretty damn sure that the zoom in on planet was not what I changed. For fuck's sake. What is with this? I double checked that I was editing the correct one. But apparently I wasn't. So that's focus on planet. Let's check this. Yeah, okay. So for some reason, I edited the wrong one again. I swear I double-checked, though. That's really weird, okay? So this is going to be zoom in on planet. And then this one's going to be focus on planet. Baba May says, is this pre-recorded? Nope, nope, it's not pre-recorded. I'm just so boring that nobody watches. Feel free to ask any questions you've got. All right, so now what we have here is a setup where this gas giant should have an animator that has its zoom turned on, but it doesn't. There's no animator attached to the gas giant clone object. Oh, did I just not put an animator on the gas giant because I'm just not very bright? I didn't put an animator. Okay, so the problem with that is that I forgot to actually put an animator on the gas giant, so that's just me being silly. Just grab this animator, copy it, and then paste it on the gas giant. Anything else that's missing one? How about the hot planets? You got an animator? I think everything else does. I don't know how I screwed that up. So now we've got an Earth-like. We click here, both of them zoom in, and then they refurb it. They do this effect where they figure out what's going on there. And then they're at a medium resolution. In this case, they're at 256 pixels wide. And if I click again, that zooms in, and I get the full resolution, except for it barfed. That's interesting. Why is it barfing? It didn't have any problems yesterday. So I think the problem is that this is pulling a different LOD. Okay, I think I know what the problem is. I think that the issue is that it's happening on just the exact wrong frame, and it's ending up getting a set of textures that is the zoomed out size, and then zooming in and thinking it's going to do the math on the zoomed in size. So to do that, all we have to do is make sure that we're a little bit less picky about our LOD. So we're just going to make this 0.9. And we're going to make this 0.22. All right, there we go. So you can see that what happened there is I screwed up and accidentally lowered this too much. Try that one more time. That's better. So we unfortunately didn't get any planets that have moons, so we're going to go ahead and try that again. There we are. So if we click on this planet with a moon, yoop, and now they're both going to do a recalculation there. That's just fine. And then if I click here, it's going to zoom in, and we're going to get a full-scale recalculation. Now at this stage, what I'm actually going to do is pop up robots, and they're going to be like, oh, look at this moon around this gas giant. However, there are still some things that we need to do. For example, when we are moving the planet like this, you can see that the camera is doing this really strange struggle. Well, that's because what I've told the camera to do is to move so that it's in front of this planet at all times. And so when I tell it to move away from that, it kind of lerps back to it, and we get this rocking. What I actually need to do is have the camera mounted on a tripod or something, an arm, and the arm gets centered around the planet, and then I can swivel it. Because we're going to want to be able to look at this. Well, actually, we're going to want to spin the planet, not the camera. Okay, that's fine. We'll do that right now. Well, actually. So in our clicking system here, we've got this situation where if we've got some horizontal stuff, we do this. But that's only true if we are in specific modes. So we're going to go ahead and switch state here. So if we're not in any of the planet-specific modes, then we move our camera. But otherwise, we're going to want to move or rotate the planet that we've picked. So to do that, we're going to just do selected, .transform.rotate, and then is it angles and then axis? No, it's axis and then angles. So it's going to be vector3.up, and it's going to be time.delta time times 60, and then we're going to give it a space.world. There. So the problem with this at the moment is that we are actually not looking at the planet very well. We're looking straight down the side of the planet, meaning that half of the planet is always going to be in shadow. Well, the easy way to fix that is here, vector3 ideal pos equals selected.transform.position minus vector3.forward times 3. We're going to go ahead and make that forward times 2, and then also minus vector3 dot left. Because that way we'll be a little bit closer to the sun, and we'll be able to see more of the shiny side of the planet. So just to test that, if we click here, okay, so I did the wrong thing. Vector3 dot right. Oh, because I was subtracting. But the other thing that's happening here is this is rotating. Oh, sorry. I forgot to tell it to only rotate if we were pressing a rotate button. So it was just rotating as fast as it could all the time. No wonder it wasn't looking quite right. Click. Yoop. That's not bad for a Game Jam game. Click again. Rah! Yum, 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 yum. Nice. And then click. City, 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 city. We've definitely got a problem with one of our enums, but we'll figure that out later. Sorry, not enums, lists. Yay, cities. All right, so this is the basic idea. We are going to be allowing you to zoom in on cities and stuff. If we zoom out, it's going to recalculate back down. That'll free up the 1024 so that when we want to, we can pick another planet. Now, the other problem we've got is that when we're not, that's the graphics. We can close that down now. When we are not selected on something, we don't properly attract to something. So camera tracking doesn't work if there's no selected. So if we're not selected, then what we're going to want to do is have a vector 3 ideal pos equals selected, no, is equals transform dot position, and then we'll say ideal pos dot z equals 0. I think it's z. Might be y. Might be. I think it's probably y. And then we'll lerp. And then what we're going to want to do is look straight ahead. So transform dot look at transform dot position plus vector 3 dot forward. There you go. Let's take a look at this gas giant because the gas giant lost last time. Shoof. So right now we have no ability to look up or down. We can fix that though. You can see here we can spin it, and we click again. Nope. We get the full detail. And now remember, this is going to have robots talking about what the planet is, how far it is from the sun, all that jazz. It's just that we haven't put that in yet. This is a pretty boring moon, but we can settle here. Minerals. Yeah, there's definitely something wrong with one of our pieces of code. We'll have to figure that out. I can actually go ahead and do that now. There's no reason to wait. So it's here in the city. It might be this guy, but I don't know why that would be. Well, I suppose what we can do is just comment it out and see whether or not it stops barfing. Oh, I should have waited until it recompiled. There we are. So we click, zoop, fire. God, that looks good. Okay. Click. Click, 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 click. So that is it. Okay. So it looks like if I do take the key collection, it doesn't help at all. So I'm going to have to go ahead and do something annoying and stupid, which is par for the course. So the problem is key. So the problem is that the key collection, I can't go through the dictionary with a for each while also modifying the dictionary. So I got the key collection thinking I could go through the key collection with a for each. But if I modify the dictionary, then the key collection counts as out of sync, even if it didn't affect the keys. So in the end, I'm going to have to take the key listing into a string, array of strings, and try it out. Now, we will never be able to land on a gas giant in the actual game. So, we're goofing around here. Wow, gas giants take forever. I didn't optimize them at all because I figured that I wouldn't be going in this close to them. But now that I'm going this close to them, I can safely say that that is too slow. Whew. Wow, that's bad. I wonder if I should have like an emergency thing where if it's taking too long per frame, it just like goes, oh wait, this is taking way too long, and just reduces the scale. Well, either way, this is how it looks. This isn't a gas giant, is it? It doesn't look like a gas giant. It looks like a moon. It is. It's a moon. Why did a moon take that long? That was really, really long. No, it has to be a gas giant, doesn't it? It is. It's a gas giant. It just looks like a moon for some reason. That's frigging weird. Huh. That shouldn't look like that. It should have all sorts of fun stripes, but for some reason it's not. That must be a bug that I haven't found yet. Maybe that's why it's so slow, because there's something completely screwy about it. Maybe it was rendering twice or something. If we click on this guy, yoink. Okay, so you can see that they both have the same texture. There's clearly something wrong with the texture request system. It might be that they, no, they don't have any of the same textures. So why do they end up with the same texture? Let's debug this, and then we might call it a day, because it's been a while. So if we click here and pull this up, you can see that they both have the same visuals. So if we pause this, and what was this? This was the first Earth-like, I believe, or was it the second Earth-like? It's the first one. No, wait, it's the second one. Okay, so it's this second Earth-like. There it is. So if we take a look at the Earth-like and its moon, they have same textures. So if we click here, you can see that these are 256 by 128, and they look like this. There's no name for these. They don't have the textures aren't named. But if you take a look at the moon, we're going to see the same exact albedo. It looks like there is a bug where if they request a texture, they get the same texture back. They shouldn't. If I zoom in, this is going to properly compute because now they're different size textures. But why would they have the same texture the first time they do a check? The planets, when they grab themselves a new texture, they release all of the textures they currently have, which is none, and then they load all the textures by doing a get texture LOD. When they do a get texture LOD, it comes up here, and it checks the width and the height, and it uses get texture width height. When we get the textures, what it does is it goes through its pool, and it removes any null values in the pool, and then if it finds a texture that's in the pool, it returns it and removes it from the pool. Otherwise, it creates a new texture and does not add it to the pool. So somehow this is resulting in these two guys getting the same texture back from the pool when we zoom in. If we take a quicker look here at this Earth-like, here, this guy. That's a gas giant, not an Earth-like. I think I just forgot to set it to Earth-like. They're all gas giants right now. So this has a bunch of textures, and then it says that there are zero textures in the texture pool. Now, if I were to click on this, so we haven't yet got any values out of this. So if we step forward until the end of the animation, they're both going to attempt to recalculate. Like that. And you can see that it created 8 new textures. With 8 new textures, there should be 8 completely different textures. For some reason, the textures are the same, but is it the textures that are the same, or is it something wrong? The moon is inside this planet, and the result is that it is accurately doing all of the moon's calculations for itself. So what we've got to do is, here in the planet, when we grab all of the target elements that we're going to process, we need to stop anytime we hit another planet. The problem is that we don't really have any good way to test and see. So I guess there is one way to do it, and that is to manually dig down ourselves, which isn't, I guess, too bad. So we look at the proxies list. Here it is. This is how we get it. Proxies get components in children. So if we got a child that is a moon, we end up with a situation where it provides all of its proxies to us, and we calculate those as well. So what we actually need to do is get a list of proxies that is much, much more restrictive. So proxies.clear. And then what we're going to want to do is have a texture proxy array for specific sets of elements. So protected void add proxies for transform T. And so we'll just say add proxies for transform. And then down here, we're going to go ahead and have this get the textures from that transform only. So it would be get components proxies. So it'd be texture proxy array, or can I do it with a list? Get components texture proxy. And I can give it a list. The question is whether or not it clears out that list, and I don't actually know. I hope not. We'll find out real soon here. So we're just going to get it from transform. And then what we're going to do is we're going to go through each of the transform's children. So for each transform T in T, if transform kid in T. And then we'll go ahead and say planet P equals kid.getComponent planet. If not P, add proxies for kid. And that will probably fix it. We will find out. However, we may have a... Oh, we don't. Okay, that's fine. So... no planets that have moons. Try that one more time. There we are. So this has a moon. When we click on it, we should now get two entirely separate objects. That was too fast, though. I don't think it ended up showing all of its proxies. So what we're going to do is we're going to dig in and see whether or not it has all of its proxies set up correctly. So here's the proxy list, and you can see it has a size of 0. And this proxy list has a size of 1, which means that when we pass it a list of proxies to fill, it doesn't add them to the list. It clears the list. So what we need to do is have it be a list that we texture proxy proxies equals t.getComponents texture proxy. And then we'll go ahead and do a for each texture proxy TP in proxies proxies. Come on. .add TP. Which is really kind of stupid and a lot of extra work that we don't need to do, but it has no way for me to tell it to I would have to do something annoying in order to make it do anything else, and it's a game jam game, so annoying is not something I care about. I'm not going to do it. If it's annoying, it's not going to happen. So click here and zoom up, and all right, this time we've got it right. That is how it's supposed to work. And if we were to actually take a look at the scene view, we would see they are quite different. See? So in that respect, we can now actually click on these things as we want to. Oh, that's interesting. Excuse me, sorry. Okay, so there's something wrong with when it shrinks. It's obviously the inverse situation of where we were before, where if it is at 0.25, if it shrinks to 0.25, it somehow stops just a second before it gets there. So here in the animations, we're going to go into our zoom out on planet animation, and we are just going to drag this back. That should fix it. So we click, zoom in, zoom out. Perfect. Now another option is we can make it so that when we're zooming out, that doesn't go that small. In fact, that's a little too small. Let's go ahead. I thought it was going to be smaller on the screen than that when I initially created this. So when we create our sizes, let's make this 64 instead of 32, because 32 is a little too small. All right. So it seems like we're in a good place to stop. It has only been an hour and a little bit. I expected to run for longer, but I'm not too worried. I have a lot more stuff to do today. I've got to finish winterizing my windows for starters. But I have tomorrow off. That's a surprise from my boss. Apparently there's a holiday tomorrow, and I didn't know about it. So what we're going to do is do a lot of work tomorrow. I plan to do it on Saturday. Why not do it on Friday if we have the option, right? So if you stop by tomorrow, you're likely to see some of my work on making the robots talk about the planets that you're trying to get. Should be fun. Go ahead and let me know if you have any questions now. I'm going to just take some screenshots for the next couple of minutes. There's nobody watching, so I'm not going to get any questions. But you know, if you do have questions, you can ask. These are some tiny cities. There we are. We're just going to go ahead and take some screenshots. Ye planet exploration. Indie dev Procjam. Oh, there's no moons. I actually should have done this. Let's erase that and try again with someone that has moons. Well, I didn't actually want to grab the moon, did I? Let's shrink that back down and grab the planet instead. Wow, there's not much surface area on this planet, is there? That's fine, I suppose. Boom, and done, right? That's fast. So we'll just go ahead and add a city here. Yeah, let's go over the fiery planet here. Oh, we'll just take a screenshot of a lot of them just all at once here. Can I make this wider? I should have thought of that beforehand, shouldn't I? Oh well. All right. So I'll see you guys some other time, and hopefully you will enjoy playing a silly little game when it comes out on Sunday. Thanks for your time.